In this video, we're going to start looking at Chapter 5. There's a little bit of an intro I want to look at before we get to Section 5.3, because that's where we're going to start, but there are a few things you need to know before we actually get there. So here we have some background information. You've probably worked with angles before, and the measure of an angle is the measurement between two intersecting lines, line segments, or rays. You start at the initial side and you end at the terminal side. So you can see this in this picture here. The horizontal line is our initial side, and the angle is how much we're turning to get to the terminal side. So that means it's a rotational measure, not a linear measure. So it's how much we're turning rather than a straight distance. Now, arc length is the length of an arc, and in this picture it's represented with the letter S, so you can see a little circle here, along a circle of radius r, which is subtended by an angle theta. So what that means is take the angle theta and take it all the way out until you hit the edge of the circle, and that's going to be where your arc is. So what this arc length is that it is a portion of the circumference between the initial and the terminal sides of the angle. Now, something that you may or may not be familiar with is measuring angles in radians. So it's so common for us to use degrees because that's what we're familiar with, but radian measure can be a lot easier to work with, so that's what we're going to start introducing. The radian measure of an angle is the ratio of the length of the circular arc subtended by the angle to the radius of the circle. In other words, if S is the length of an arc of a circle and R is the radius of the circle, then the radian measure, so the measure of the angle in radians, is S over R. But notice that both our S, which is the length of the arc, and our radius R are actual lengths. If we divide out those units, then they cancel out, and that means that radians are a unitless measure. So if you have an angle, you don't have to write radians after it. If you see an angle that doesn't have degrees or the degree symbol on it, then just assume that it's radians. So if you think about a circle with radius 1, that's called the unit circle, then the circumference of any circle is 2 pi r. But for this circle, if we're letting the radius be 1, then the circumference will be 2 pi times 1, which is 2 pi. So that would mean that the length of the arc for one full rotation, one full way around the circle, which we know to be 360 degrees, is 2 pi, and that's in radians. So one rotation, a full way around the circle, that we know as 360 degrees, is 2 pi radians. Half a rotation, which we normally think of as 180 degrees, is going to be pi radians. And then 1/4 rotation, known as 90 degrees, is going to be pi over 2 radians. Now, we're not going to assume that you can have this down and know what all these radian measures are in your head. So we're going to practice converting back and forth. So we're going to start with some radian measures and convert them to degrees, and then vice versa. So if you're starting with radians and you want to get to degrees, we're going to multiply by 180 degrees over pi. If you want to go from degrees to radians, we're going to multiply by the reciprocal of that, which is pi over 180. Now, the way I remember this is that radians typically have pi in their answer. So if I want radians, then I want pi in my numerator. If I'm switching from radians to degrees, I don't want pi anymore, so my pi is going to be in the denominator to help cancel it out. So starting with pi over 3 radians, to go from radians to degrees, we multiply by 180 over pi. Well, pi over pi, those cancel out, and I'm left with 180, and that's in degrees. 180 degrees divided by 3 is 60 degrees. So pi over 3 radians is 60 degrees. Next up, we have 7 pi over 4 radians. And 7 pi over 4 times 180 degrees over pi. The pi's cancel, and we are left with 7 times 180 degrees over 4. And I don't know that one off the top of my head, so I'm just going to use my calculator. 7 times 180 divided by 4 equals 315 degrees. Now we're going to go the other way. We're going to start with degrees. So we're starting with 120 degrees. To go from degrees to radians, we're going to multiply by pi over 180. And that's in degrees. So the degrees cancel, and we're left with 120 pi over 180. If I divide both the numerator and the denominator by 60, then this reduces to 2 pi over 3. If you ever look at that fraction and you're like, I don't know how to reduce that, remember that your calculator can do this. So if I do 120 divided by 180, I'm going to do it without the pi because I know there's a pi in the numerator. I can then press math, enter, enter, and that tells me 2/3. And just remember that your pi is in the numerator. So then we're looking at 225 degrees. And we're going to multiply that by pi over 180 degrees, which gives us 225 pi over 180. And I'm going to use that neat little math enter enter trick. 225 divided by 180. Oh, that's actually not that bad. Math enter enter. That's 5 over 4. And don't forget you had a pi in the numerator. So that's how many radians 225 degrees is. Now, something you've probably looked at before are the quadrants of the Cartesian plane. We're going to be using these pretty thoroughly, so you need to be confident in the signs on your x and your y terms. So we say that the upper right-hand corner is quadrant 1 because most of the time we are going to start with the positive x-axis as the side that we start on, and we're going to rotate from there. So first we have quadrant 1 where both x and y are positive because we went right and up. Next up we have quadrant 2 where x is negative and y is positive. Then we have quadrant 3 where both x and y are negative. And finally we have quadrant 4 where x is positive and y is negative.